Today we're going to talk about the law of cosines and really how we're going to derive or how we're going to come up with the different formulas for the law of cosines. And we're basically going to concentrate on the first one. If you can do the first one, you can do the other two. So we have three different formulas for the law of cosines. You have a squared is equal to b squared plus c squared minus 2bc cosine a. And then we have b squared is equal to a squared plus c squared minus 2ac cosine b. And then for the last one, we have c squared is equal to a squared plus b squared minus 2ab cosine c. So again, let's see how we come up with this first one. Let's go to the next board. To come up with the proof, what we're going to do is start with an obtuse triangle. It has one angle that's greater than 90 degrees, and that's this angle right here, C. And then we have two other angles. Now, we're going to be concerned about this angle right here. We're going to call it theta. Now, what I want to do, whenever I'm doing a trig problem and I'm not sure what to do next, it's always good to try to find a right triangle somewhere. And we could do that by just drawing the altitude. It's a 90-degree angle. And the reason why this is important, if you are doing a trig problem and you have a right triangle and you're trying to find the unknown angle or unknown sides, it's very easy. You just use your sine, cosine, tangent, or whatever. Once you have an angle that's greater than 90 degrees, or a triangle that does not have a 90-degree angle, then you have to either use the law of sines or the law of cosines. But if you could create a 90-degree angle, then you could use the other identities to come up with a formula, and that's what we're going to do here. So I'm going to look at this side right here. I'm going to look at the right triangle on the left side. And what I'm interested in is this length and the length of the height. Now it's a 90-degree angle, so all I have to do is say, well, I know that the cosine of theta is equal to what? Adjacent side over the hypotenuse for a right triangle. So that's just going to be this distance right here. And let's just mark this as a, let's just say D. So we have a point. So we're just going to say that's distance AD. That's the adjacent side over the hypotenuse, which is B, or the length of AD is just equal to B cosine theta. So I'm going to put B right there, cosine theta. Now pause the video and see if you know how to come up with the height, formula for the height. Okay, now for the formula for the height, I'm going to erase this. Here's the height. We'll say h. Now we know that the sine of A, or the sine of theta, is equal to the opposite side h over B, or we just say that h is equal to B sine theta. So that's right here. B sine theta. Now, how would I find the distance between D and B? How would you come up with that? You pause the video and look at it, and then we'll talk about it. Okay, so the distance between D and B. It's easier than we think if you haven't got it yet. We know that this entire distance right here, the entire distance, and I'll move this line up just a little bit so you can see. I'll just do it right over there. This entire distance is just C. So for this right here, I'm just going to say that is equal to C minus B cosine theta. So that's the distance between D and B. Put my arrow. Now, how can we come up with some type of formula that we could deal with? Well, remember, the first we worked with this side, and we used that right triangle using sine and cosine to come up with two of the distances in equation form. Let's look at this side over here. And we're going to do the Pythagorean theorem. But we're going to, of course, use trig. So, what we can say, and I want to do that in yellow so that we could see it. Can I say that the hypotenuse squared is equal to the opposite side squared plus the adjacent side squared? Or you could also say, if you wanted to, hypotenuse squared is equal to the adjacent side squared plus the opposite squared. Either way, they'll both work. So all I have to do, I know that the hypotenuse is just A, and I say A squared, and set that equal to the opposite side is B sine theta. Make that a little bigger theta. B sine theta, and that's squared, plus the adjacent side is going to be what? C minus B cosine theta, and everything to the second power. So we have it. So now we get into some algebra. And it's going to take a little bit of time, but you're going to find is that it's pretty simple at the end. It's just a lot of work. So let's begin. I'm going to rewrite this as A squared and it's equal to, well, B sine theta squared. This is just B squared sine squared theta. And if we do this, C minus B cosine theta squared is just C minus B cosine theta times C minus B cosine theta. We're using FOIL. we come up with c squared minus 2 bc cosine theta, and we have that, plus what? A negative times a negative is a positive, so plus b squared cosine squared, and we have our theta. So we go back, let's look at board 1. So we go back to board 1, and we say, how are we going to come up with a squared is equal to b squared plus c squared minus 2bc cosine a? If you look at it, is there a common factor that we could pull out? If you want to pause the video and see if you can find it, go ahead and do that. So the common factor, use that right there. There we go. Our common factor is that b squared. So I'm going to rewrite this whole equation. And I'm going to say it's a squared is equal to b squared sine squared theta plus, so we've taken care of this, and now I'm going to add this one next, plus b squared cosine squared theta, and then I'm going to put this in, and hopefully I have enough room. I might have to write smaller, plus c squared minus 2 bc cosine theta. Well, that worked pretty good. So let me factor out the b squareds right there. So we have a squared is equal to b squared times, in parentheses, sine squared theta plus cosine squared theta. And whenever you have sine squared theta plus cosine squared theta, that helps a lot, improves. And I'm going to show you in a minute. So we've done that, and we're going to plus c squared minus 2bc cosine theta. And we are almost done. What is sine squared theta plus cosine squared theta? I'll put it in yellow here. That's just equal to 1. This becomes a 1. Sine squared theta plus cosine squared theta is equal to 1. So a squared is equal to, what's b squared times 1? Of course it's b squared. So b squared plus c squared minus 2 bc cosine theta. And we said that theta is equal to what? Angle A.